Alrighty, we're going to go ahead and get started. We're going to get started in a little bit different way. I'm going to stop sharing my screen for a minute so that you can get a full screen of, um, let's do it. All right, can y'all see my screen now? See my camera? I have it facing down at my desk with my materials. Can you guys see that? All right, I got some yeses, cool. So we're going to start a little bit different than we typically do. And the reason that I'm starting this lesson in this way is as you move to geometry next year, a lot of geometry is a little bit more hands-on than algebra. We can prove things a little bit more hands-on than we could in algebra, right? So if we're solving an equation, it's pretty challenging to show a model about how to solve that equation. We're kind of talking through steps and walking through steps. One of the things that I really admire about the way that Dr. Adamson in particular teaches geometry is she tries to prove a lot of things. Rather than just telling you a new rule, she tries to prove that rule is true with doing some kind of hands-on activity. So we're going to start out today with a new rule that we're going to be learning, and we're going to prove this rule together. We're going to learn about this rule together. So the first thing I'm going to ask you to do with your materials is I'm going to ask you to draw a rather large triangle on your sheet of paper using your straight edge and your pencil. And it does not have to be a specific type of triangle. We haven't learned the types of triangles, but you might know some of them already. There's right triangles, there are isosceles triangles, there are equilateral triangles. I just want you to draw a random triangle. So you don't have to try to match the triangle I'm drawing. I'm just going to draw a random big triangle on my paper. And fun fact, the color pencil that I'm using is from San Francisco, and the color is Golden Gate Bridge. It's the exact color that the Golden Gate Bridge is painted in, and that's the color pencil that I'm using right now, so that's kind of fun. Random fun facts. Once you've used your straight edge to create that large triangle, I'm just going to ask you to take your scissors and cut that triangle out. And I'll give you guys a couple minutes to do that because I know some of you are a little bit challenged with scissors and rulers. When you have your triangle cut out, go ahead and give me a thumbs up on your name so I know when we're ready to move forward. Judging by the speed that the little blue hands are popping up, it looks like I was correct. Some of us are challenged with scissors and rulers. Cool. A lot more blue hands popping up now. Cool. Okay, so the next thing that we're going to do is you're going to take your triangle and you're going to take your highlighter or your marker or whatever it is that you brought. And I'm going to ask that in each corner, you're going to draw kind of a little part of a semicircle. And then you're just going to lightly shade in that corner. I don't want you to go crazy with the highlighter on it because it's going to get soggy and that's not going to be fun. But I want you to kind of do that in each of your 3 corners. We're going to draw a little part of a semicircle and just kind of color it. And what we're doing is we're coloring in the 3 angles, right? So we're coloring in the 3 angles of the triangle. Of course, we call it a triangle because it has 3 angles. Just kind of lightly colored in the 3 angles of the triangle. And I just lowered everyone's hand. So when you have your 3 angles colored in, go ahead and raise your hand again so I know that you're with me. Cool, lots of blue hands, awesome. The next thing that I'm gonna ask you to do is I'm gonna ask you, can y'all see my screen again? Are we seeing my screen? Because I'm seeing Eddie's screen and it's just black. So I wanna make sure y'all are seeing my screen. Okay, I see some yeses and some nos. If you go into your, if you go to kind of your view, your gallery view, if you just click on me, if you click on mine, it should be the one that shows up as the primary screen. So if you're seeing someone else's name or screen, just double click on mine and I should pop up as your primary screen. All right. So next thing we're going to do is we're going to cut out these angles. We're going to cut these angles out. So I'm going to just take these little angles that I have just colored in and I'm going to cut them out. And I'm going to end up with 3 little pieces of pizza here. I'm going to get 3 little pieces of pizza. I still have my triangle here, but my triangle is now missing all of its angles. It's a 0 angle now, no angles. I have all my angles sitting right here as little pieces of pizza. And I'd like for you all to put your pieces of pizza together. I want you to put your pieces of pizza together like you're trying to build a whole pizza again. And I want you to tell me, I want you to think for a minute about what you notice. I'm going to do the same thing. You do it with your triangle. We all have different triangles, but I think we're all going to see something similar when we put our pieces of pizza together. So take a moment and put your pieces of pizza together. And right now you can only see my pieces of pizza and your pieces of pizza, but is anyone noticing something that your pizza and my pizza have in common? Anyone seeing something? Diego, what are you seeing?
That they're both creating like half a circle.
They're creating half a circle, right? And how many degrees are in that half a circle?
180.
180 degrees. So we should be seeing on every one of our screens right now that our 3 angles came together to create a straight line. They created this straight line right here. They created a semicircle. No matter what triangle we started with. Did anyone start with a triangle very different than mine? Anyone start with something a little bit different than my triangle? Maybe something with a right angle or something that had a big obtuse angle in it. Anyone have a weird triangle to start? Albert, you did?
Yeah, I did.
And what did you notice on yours, Albert? Did you still? Go ahead.
Well, first of all, the small triangles I cut out, they're not all even. Like they're a little bit different
Mm-hmm.
inside.
Okay. And then still, what happened when we put all those angles together?
It still became sort of two.
Yeah. It still
Circle.
became that straight angle, right? It still became that semicircle. It doesn't matter what angles we start with. So we just did 50 different triangles. Now, if we were in class, we'd be able to look at each other's, right? We'd be able to see everybody's different triangles and still see that they're adding up to 180. But our purpose here, our purpose in this little activity was to very quickly lead us to a new rule. And so I'd like you to think about how you might want to finish in this new rule now that we have a new rule. How might we want to finish that rule? You can go ahead and type in the chat this time if you think you know how you want to finish that rule. I see some folks in that chat, and I see a lot of folks in that chat now. Great. The angles in a triangle sum to 180 degrees. Ooh, that's not what I wanted. I wanted a pen. To 180 degrees. If we were to write that kind of algebraically, we could give each of these angles a different letter like A, B, and C. And we would write that always A plus B plus C is equal to 180 degrees. In any triangle, the angles sum to 180 degrees. And we are going to today, as we work through some practice problems, we're going to be relying on that rule. Now, I want you to keep in mind that our old rules don't go away. We're still going to look for vertical angles. We're still going to look for linear pairs, complementary angles. We might look for alternate interior or alternate exterior angles, corresponding angles. All we're doing now is adding one new rule to this, and that is when we see a triangle, the three interior angles of that triangle need to sum to 180 degrees. All right, so let's look at some problems and try to apply that rule. I've got two up here. We're going to do half of today's classwork in our session over the next 15-ish minutes, and then you will be able to finish the classwork on your own after that. So let's take a look at these first two questions, number 1 and number 3. Starting with number 1, what information was given to me in number 1 that might help me figure out the missing angle? Any thoughts on how I could do this? And as we do these questions, you need to write down the picture. So if you'd like to take a moment right now to sketch that picture out with a straight edge, you can go ahead and do that. And Juan and Albert, I will come to you guys in just a minute. I want to give everyone a chance to sketch these two questions down real quick in their notebook. It's very important in Geo that we write on stuff. If you have access to a printer and you've printed this, that's fine. If you have access to a printer and you want to print it afterwards and fill in the information for your notes, that's fine. But if you don't, just take your straight edge and do your best to draw a picture that looks kind of close. All right, Juan. So as we look at number 1, can you give me some thoughts on what we might want to do with number 1?
You might want to like add those two angles.
Okay, so I'm going to add 65 plus 57, and that accounts for already how many degrees? Did you do that?
No, let me do it real quick.
Okay.
122.
122 degrees. And what do we know about the sum of all of those angles in a triangle?
That they always add up to 180 degrees.
They all need to add up to 180 degrees. So how am I going to find that missing angle?
You get like 180 and subtract it to 122.
Okay, and 180 minus 122 is going to leave what in that last angle?
58.
58 degrees. Any questions on that first one? If you don't have any questions on that first one, go ahead and try to do number 3 on your own. And if you're able to figure out number 3, I want you to raise your hand. All right, a really good amount of hands. Can you leave your hand up for me if you're willing to explain how you figured it out? If you don't want to help explain, you can lower your hand at this point. Look at all those hands disappear. Oh, so sad. Miss Tessa, can you go ahead and explain what you did?
I added the two angles that we had. I added 130 plus 20 and I got 150.
Mm-hmm.
And then I subtracted 180 by 150 and I got 30.
Absolutely correct. Perfect. We know that they all have to add up to 180. So if we add the first two, we get 150, and we need another 30 degrees to get up to 180 degrees. The longest part of this first couple questions was copying the question down. This is very quick and easy math here. And so that's going to kind of be the case on the first half of these questions we're looking at today. I'm going to go to the next two. And there's just a little bit more math that's happening in these. So I'd like to give y'all a minute or two to see what you can come up with. On number 5 and number 7, I want to see what you can come up with. So I'll give y'all a couple minutes. And if you feel comfortable explaining either 5 or 7 after you're done, go ahead and raise your hand so I have some hands to select from. So hopefully these didn't stress you out too much, but they definitely increased in difficulty really quickly, right? We went from something that was real quick mental math, one step, to something that has multiple steps, and nobody has their hand up. So I'm wondering if anybody's willing to explain what they did, or if we want to talk about these together, if we need a little bit more guidance on this question. All right, not seeing many hands. So I'm going to go ahead and explain 5, and maybe we can use 5 to help us figure out 7, okay? So on number 5, the first thing I might see, or the first thing I definitely see on number 5, is I see this triangle. You guys see this triangle right here? And that triangle, because we're doing a lesson about triangles, makes me think immediately that, oh, all the angles need to add up to 180, right? But the problem is there's two things missing here, right? And I can't find those two unknowns at once. I'm trying to figure out what that is, x, and what that is, y. I can't figure those both out at once. So I'm going to ignore that triangle for a minute. And this is one of the biggest challenges in geometry, is that sometimes we want to ignore the big picture and focus in on something that we can deal with. And this right here is something we can deal with. This is a straight line that's being cut into two angles. And the first angle here, this first angle is 137 degrees. And I know that a straight line has to add up to 180 degrees. And so if this is 137 and the straight line is supposed to add up to 180 degrees, that means that this angle has to be 43 degrees. Because now this angle right here, which is obtuse, and this angle right here, which is acute, those two angles can now add up to 180 degrees. And so even though this was a triangle question, it kind of goes back to what I was saying to you just a couple minutes ago. Even though we're talking about triangles right now, we can't forget about stuff like linear pairs. And right here, there was a linear pair that allowed this to go to 43 degrees. Well, now I have two angles in that triangle. So now I can go back and see this more like a whole triangle. So let's focus on the triangle next. Now I know we've got a 43 and a 102. Well, 43 plus 102 is 145 degrees. If that's 145 degrees, that's going to leave what left over in this last angle of my triangle? 180 minus 145, which is 35 degrees down here. And now, last thing that I'm going to see is I'm going to stop looking at it as a triangle once again. And I'm going to start seeing it like a linear pair again. I've got an angle cut here. One piece is 35. The other piece is 180 minus 35, or 145 degrees. So I want to pause there for a minute because that was a big jump. We jumped from finding one angle in a triangle to having to find three different angles in there. Okay, so I want to pause there and ask what questions you have. Or allow the possibility that maybe you're just saying, I don't get it, and you need to hear it again. Abby, what's up?
I don't really understand like how you did the question.
How I did what?
Like how did you get 145 degrees on the outside?
On the
Yeah.
outside? Because I'm
Yeah.
back to having a straight line here. So that last step is, this is a straight line.
Okay.
And I
then
know that this piece is 35, and what does a straight line have to add up to?
180.
180. So 180 minus 35 leaves 145 degrees.
Oh, okay.
So we really have to be able to see this in three different steps. I'll review those steps one more time and see if that assists, okay? The first step is I'm seeing this as a linear pair. Right here, I'm just seeing a linear pair. Right? I'm ignoring the rest of the picture. The rest of this picture doesn't even exist for me right now. It's almost like I walked in and all I saw was a question that looked like this. And if you have to turn your brain 90 degrees, literally if you have to turn your head 90 degrees so that it starts to look like this to you, so that you can see that what we're looking at is a linear pair, then do that. Turn your brain, turn your head if you need to, that's okay. That 137 is gonna mean that the inside angle right here has to be 43. Now that I figured that out, I can look at the triangle because now there are two angles I know in this triangle and only one that I don't know. So now I can add those two together and subtract from 180 to figure out that the missing angle in the triangle is 35. And once I know that that is 35, I can see once again that this is a straight line being cut into 2 pieces, and that has to be 145. It almost helps us to work backwards for a moment. So I'm going to erase that one more time and give you one more kind of thought process here. Imagine this. I want to know this angle, but I cannot figure that angle out unless I can figure this angle out. And I cannot figure this angle out unless I can figure this angle out. Right? And that kind of leads me back to where I have to start this problem. Even though I want to ultimately end up here, I had to start here to get enough pieces. Does that make sense?
Yes.
Okay.
Yeah.
So let's apply that same logic to number 7. On number 7, I ultimately want to get to this. The easiest way for me to figure that out is to first figure out this. Because what relationship do those 2 angles have?
Vertical.
They're vertical angles, right? So if I can figure out the one inside the triangle, then I'm going to know the one that's across from it as well. Is there a way for me to figure out the angle inside of that triangle? Is there enough information there to figure that out? Yes, good, John Paul. We know that 30 plus 20 is 50 degrees already. The whole triangle has to contain 180. So 180 minus 50 will lead us to 130 degrees. And if that's 130, then the vertical angle is also 130. Do we have any questions so far? Or any confusion that I can help clear up? Because I think what happened was last Thursday, we didn't ask a lot of questions, and then we had an assignment Friday and we all kind of freaked out and didn't do so well. And then we came back together yesterday and it was clear for a lot of you. It helped clarify what happened on Friday. So if we can make those clarifications now, then we won't have to come back tomorrow freaked out. Anything I need to clarify for you before we move forward? Okay, let's go to the next couple questions. We want to know this angle. In order to figure that out, we're going to need to know this. And in order to figure that out, we're going to need to know this. Give it a try. All right, can I get somebody to help me out here? Can I get a volunteer with a blue hand to assist me in explaining this one? Okay, Juan, go for it.
Well, we could figure out like the angle on the bottom because we have the 20 and the 40.
Okay,
That's a triangle, so it has to add up to 180. So
perfect.
then you subtract, like you get 180 and subtract it by 60.
Mhm.
And that gives you 120.
Okay,
And then 120 is a vertical angle with the one on top.
perfect.
So that's 120. And then with those 2 pieces, you add them. And then you can find the last one.
Okay, so 120 plus 39 is 159, which
And
leaves
then,
us a last 21 degrees at that last spot.
yeah.
Yeah?
Yeah.
Cool. Awesome. Thank you for helping. Looking at any questions about number 9? Okay, let's go check out number 11. Let's take a moment on number 11. And again, if we start identifying what we need to know, we want to know this. The only way we're going to be able to learn that is if we can figure out this. And the easiest way for me to figure out that is to know this. See what you can come up with. And go ahead and give me a blue hand when you're done if you're ready to, if you're willing to help explain it. Alrighty, Crispy, why don't you go ahead and help us explain this? Go for it, Chris.
So basically, to get the question mark, you have to find the other angle of that triangle,
Mhm.
and to get that it needs to be a linear pair of the other one. So you add those two angles of the bottom one,
Of the
and
bottom triangle. So we're gonna add 84 and 36.
and then we minus that with 180,
Okay, and that gave you what?
60.
That's 60 degrees, I agree. Okay.
And the linear pair, it's like 60 to the other one.
So I don't see a linear pair here. I do see a relationship with those two angles. What are those two angles adding up to? This angle right here and this angle right here, what do they add up to?
90 degrees.
90 degrees. So they're not a linear pair because a linear pair is going to add up to a straight line. It's going to add up to 180 degrees. Does anyone know the word? Can you help Chris with the word that of two angles that add up to 90 degrees? Just throw that word out there. Go for it.
Right angle.
It is a right angle. And what do we say about two angles that are a right angle?
Complementary.
Complementary. Good. That was like a very choral response. That was cool. Okay, Crispy, let's come back. Those are complementary, not linear pair, but they're complementary, which means what's the red angle have to be?
30 degrees.
It has to be 30 degrees. Okay. And now we can focus on that other triangle. Now we can start to see this other triangle right here. Because now we have two pieces of that triangle, 30 and an 86. And so what's that going to leave for the last piece?
64.
64 degrees. Good. Great explanation. Thank you. All right. Any questions on number 11? All right. Last two that we're going to do together. Got a little bit more complex. Might take you a hot minute to draw these. Might be beneficial if we have a printer to use it. Might also be beneficial if we are headed towards a start of school next year where we're still kind of virtual, that if you have a birthday coming up, maybe ask for a printer or get a job over the summer. Printer's going to become an essential supply if we're starting digital again next year. Dre, I believe 14. I believe the answer is 14. Just wash a lot of cars. Babysit a cat. Yeah, the min's 14, but only for some jobs. Yeah, even at 14, you can't go be a doctor. Yeah. But I think Publix's minimum age is 14. So you could be like a bag boy at 14. David, I'm not saying we have digital classes next year. I'm saying we don't know the answer yet. Don't start freaking out just yet, but it certainly seems like we might be on some kind of blended model where we are alternating days so we can have less kids in the building, where you'd have some digital days and some in-person days. That seems to be where a lot of planning is headed right now. So just to kind of, yeah, so Abby, let me just kind of guide you a little bit here, and some other people that are just looking at this like there are way too many things happening. So we need to know this. The only way we're going to know that is to know this. Okay. The only way we're going to know that is to know something about this triangle, which means we're going to need to know this and this. The only way we're going to learn about this is if we know this. And the only way we're going to know this is if we know this. That means that my starting spot has to be all the way back here with this straight line. That's my starting spot. So I've got a straight line, got to add up to 180. 180 minus 115 is going to give us 65 degrees right here. That will now allow me to figure out this, Abby. Once I have that, I can figure out this. I have another straight line up here that will allow me to figure out this. Then I have two parts of my triangle, which will help me find the third part of my triangle. And once I have the third part of my triangle, I can figure out the missing angle. Lots of steps on this one. Big puzzle. So let's walk through those steps now. I've got the 65. I got the 65, George. Good question, because this is a straight line right here. And if part of it is 115, the other part of the straight line is 180 minus 115. 180 degrees minus 115 degrees is 65. Once I have the 65 and the 85, those add up to 150 degrees. If they add up to 150, the third angle in my triangle is going to be 180 minus 150, which is 30. Yes, Albert, question. Ask it out loud, please.
So I got to the second last number before the question, before the finding the question mark, which is the one directly above the question mark, correct? So how do
We're
I
headed
make,
there now.
how do
Give
I
me
find
just a
the
second.
question
We're
mark?
headed there now, okay? We're going to get everyone caught up to where you got stuck,
Okay.
and then we'll have an answer. The next thing I'm looking at is this is a straight line right here. I've got a 30-degree angle and a 90-degree angle. That's 120 already. 30 plus 90 is 120. And that leaves behind this last one, which has to be 60. 180 minus 120 is 60. Looking at the top, I've got another straight line broken into two angles. So the same thing we did on this corner over here is what we're going to do on this corner over here. 155 minus 180 means that this one is 25 degrees. Now we've got a 25 and a 60, which is 85. We're trying to build the triangle, so 180 minus 85 is 95 degrees. And now, Albert, for the third time in this question, we have a straight line being broken into two pieces. Straight line has how many degrees?
90.
Straight
I
line
mean, 180.
180. And so if part of this straight line is 95, the other part of it is 85, because that adds up to 180 degrees. So the challenge here was we wanted to know this angle, and we had to start over here. We had to find every other angle. Go ahead, Crispy.
How did you get 25?
Because we have a straight line right here. And this part is 155, and every straight line adds up to
Oh, okay. I see.
180, right? So if I just looked at the picture like this, I'd have a straight line being cut into into two angles here, a big angle and an acute angle. And that acute angle has to be 180 minus 155, which is 25. What questions do we have here? Or too many questions to ask right now? Okay, let's give this a try. Let's try to do 15. We're going to challenge ourselves for a minute. We'll do our best, and then we're going to move on, because we'll come back and practice some more stuff like this tomorrow. We're looking for the question mark. The only way to find the question mark is to know this. The only way to know that is to know the other angle in the triangle. The only way to know that is to know this angle. And the only way to know that is to know this angle. So we got to follow that chain from one step to the next. I'm gonna give you 2 minutes to kind of play with this and see what happens. I'm not going to force anyone to explain, but if you think you have the answer, you think you were able to finish this, go ahead and raise your little blue hand just so I can get a feel for who feels like they've got this. Not stuck, Abby? You figured it out what to do next? Okay, cool. So Serena, you want to look at what the relationship is between those first two angles. So if I look at those first two angles, I've got two lines crossing right here. What do we know about the angles that are across from each other in that case? Okay, cool. The biggest challenge, and you're going to get so used to this in geometry, but the biggest challenge is to not get overwhelmed by this giant picture with a lot of missing information. It's to really be able to zoom in on one thing that you know how to do in that question and let that guide you to the next thing, because so often the puzzles are 10 steps, but you can't get to step 5 unless you start on step 1. And so you just have to scan that picture and see, is there anything I can figure out? And in this question, the only thing that we could figure out to get started was the angle that's across from 45, because the angle across from 45 is also 45. So anyone who thinks they got the answer, I've got some hands up. If you want to drop your answer in the chat, if you want to be brave and drop it in there and be like, I think this is it, go for it. And then we'll walk through the steps real quick and see if any of my brave folks got it right. Well, I got a couple people saying, I got some 137s dropping. I got a lot of 137s dropping. So that's seeming like that might have a chance. So let's go for it. Across from the 45-degree angle is another 45-degree angle. That's called a vertical angle. And now that I have two angles in this triangle, now that I have two things in this big triangle, I'm going to start to actually see it as a triangle. 60 plus 45 is 105. And 105 from 180 is going to leave us with 75 degrees right here. And now that I have that 75, I'm going to go back over and I'm going to start seeing this as a straight line again. And as a straight line, it's broken up into three angles. A 75-degree angle, a 68-degree angle, and an unknown angle. But those three angles, like the little pieces of pizza we started our day with today, have to add up to 180 degrees. So 75 plus 68 is 143. And if that's 143, it's going to leave behind 37 degrees here, so that those three angles can add up to 180. And now that I have that angle, I can start to see the next triangle. The next triangle is this triangle right here. And we've got 100 plus 37, which is 137. And 137 out of 180 in that triangle leaves me with 43 degrees right here. And once I have that 43, we're going to ignore the triangle for the final time here, and we're going to focus back on the straight line again. Here's a nice straight line being broken into two pieces. If one piece of that straight line is 43, then 180 minus 43 is 137 degrees. So awesome, Joaquin, Chris, Oriana, David, Abby, Lewis, and Gretchen. Awesome on 137. Good work. The rest of you will have a couple of other opportunities in your classwork. I will say that your classwork today exactly mirrors this right here. So there's two questions on your classwork that you'll need to do that are going to look exactly like this. They're little one-steppers. There's two questions exactly like this that are like two-step questions. There's two questions that are three-step questions, and then there's a couple that are these multi-step questions for you to try. Yeah, that's it. That was a longer than anticipated lesson, but it took us a little while to get through that. I'm not going to collect all of this work until Friday. So if you have things that you need to get done today, and you have kind of used up all of the time that you have for math today, you can feel free to work on these problems tomorrow or Friday, as long as they're ready by the end of the week. Okay? Any questions? Cool. So we're going to be live again tomorrow. Tomorrow, I promise you, we will not go over 30 minutes. If we hit 30 minutes tomorrow, I'm just going to be like, okay, that's all we can learn today, and we're going to move on. We won't go over 30 minutes tomorrow. And if you have any questions, let me know. Okay? Bye, y'all.
Bye, Mizzou.
Adios.
Bye. Have a good day.
Ciao, ciao. Have a good one.
Ta-ta for now, sir.
Ta-ta for
Bye.
now.